experiment which we are going to perform is the Bernoulli's experiment. And Bernoulli's theorem, as we have discussed in the class, that it is applicable for the steady state incompressible fluid. And incompressible means here we are taking the water as a liquid, which is incompressible in nature, where we cannot change the density as you know. And the most important first condition is the steady state. So this is which you can see is the apparatus of the Bernoulli's theorem. So the first step that you need to ensure is the safety of this experiment. That first of all you need to check that no windings are open. So this is the first step. After that, what we are going to do, you need to switch on your connection, and once you switch on the connection, you need to ensure that initially your bypass line should be fully open, so that no flow will be going into this tap. So initially this bypass will be open, so that you would be ensuring that your pump is the water or the liquid which is flowing is adequate with the adequate flow rate. And once you are assuring that, what you need to do, you need to open like semi-open. You are not going to open this valve fully. So based on whatever amount of flow you want for this particular tank to fill, that you need to keep. And how we are going to discuss that about the particular flow rate is, as I told you, the most important condition for the Bernoulli's theorem to apply is the steady state. So basically what we need to do, we are going to keep this bypass open, but we are not going to, once we are going to start the experiment, we are not going to keep it fully open. So we will be, regulating this flow, this valve. At the same time, we are also going to regulate this valve in the manner where the liquid can be kept on this steady state. There must not be any fluctuations in the level of the liquid. Once we are sure that the steady state has been maintained in that particular tank, then, so this is the first step. The second step is to regulate. The third step is to maintain the steady state. And the fourth step, as you can see, this is the section. You can just zoom it over here. So this is which you can see. This is the section, and this is a varying cross section. If you can see here, the diameter is large. Here the diameter is smaller as compared to the previous section, and so on. So it is a kind of varying cross section which we see in the Venturi meter. And along with these varying cross sections, the different piezometer or the piezometer tubes are being connected. So at the cross section number 1, piezometer tube number 1 has been connected. At cross section number 2, piezometer tube 2 has been connected, and so on. So here we are having 1, 2, 3, 4, 5, 6, 7, 8. Total 8 piezometer tubes. And what these piezometer tubes are going to do, as we have discussed in the classroom, piezometer is again a type of manometer or the pressure measuring device, in which one end is open to the atmosphere. With the help of it, you can measure the height, which is we are going to see in this tube. So with the help of this, you can measure the height, and of course the height is going to be dependent on the on these particular cross sections as well, right? So you will be getting a kind of curvature over here, means the maximum height will be somewhere over here and here, and the minimum height will be in these tubes. Alright, and then this is the next step, and the last step is to calculate the flow rate, that is the Q. So basically what we are going to do here, we are going to prove the Bernoulli's theorem or the Bernoulli's statement, where the summation of all the energies are constant, which all energies, pressure energy, potential energy, and the kinetic energy. Alright, so you are going to get this velocity with the help of this Q or the volumetric flow rate that we are going to measure over here. So there are again two ways by which we can measure the